Hi there. Stick around to the end of this video to hear an important announcement, i.e., if you want access to my code, find out more later. Okay, today I'm going to show you how to automate through RStudio to make calculations easier for daily tasks that you may have at hand. For instance, in my lab, we measure a lot of total carbon and total nitrogen. Now, I could continue to calculate this in Excel on a day-to-day basis or project by project basis, but I'm going to show you how you can input what you do in Excel into R to make it more streamlined and save you a lot of time. So let's begin. Okay, we're going to take our data sheet that you might form from collecting your own data and import it into R. So you still need to collect your pertinent data off your instruments, but this doesn't necessarily tell us the micrograms per milligram of carbon or nitrogen that we might want to understand remains in these samples after we combust them. So how do we calculate those? Well, we need to first form a standard curve. And what you can see in this Excel document is I've already calculated micrograms of carbon based off of what is the percentage of carbon in my standard sample, which in this case is 23.5% of my standard by weight. So therefore, the weight in milligrams of my standard times 23.5 gives us the rough micrograms of carbon in said standard. And from this, we're able to form our standard curve. I'm only showing you this now as it becomes important later as a point of reference. Now in R, we need to do the same thing. We need to calculate the micrograms of carbon in order to form our standard curve. So essentially, we're going to mirror what we do in Excel into R. Therefore, calculate the micrograms of carbon in the standards. In this, we want to create a new column. So within your data sheet, in R, we're going to create a new column. So within TCTN, we're going to mutate because that's going to help us form a new column. We're going to call it micrograms of carbon. And we're going to use an if-else statement so that way we know we're only referencing these standards. Now, in here, we can see there's standard 1, 2, 3, 4. How can we apply the same function to all four without doing too much extra work? Well, that's where you do string detect ID, and the pattern, you provide it, quote, std in this occasion. Therefore, this is saying it's going to look within your data for any character string that contains the three letters std. And from there, it's going to take the weight in milligrams and multiply it by 23.5. It's going to take this weight, multiply it by 23.5, and create a new column over here called micrograms of carbon. As we can see, 18.8, 35.25, 51.7, 25.85. And as a point of reference, it's the same values that we see here in our Excel sheet. So far we are following along just fine. Okay. You do the same thing with your nitrogen standard. Calculate that new column with your standard values. But next we have to form a linear regression. We're going to make the linear model for both carbon, TC, and nitrogen, TN. Linear model, TC area, that'll be our y-axis, by micrograms of carbon, our x-axis. Data equals TCTN, which is what we imported initially. Now, you're not going to create a figure here. You're going to get a model set of information over here. Within here, it carries the same information that you would see under the said chart here. It's going to carry this information, the slope, the intercept, the r squared, etc. And from there, we're able to use these points of reference to calculate our next set of coefficients. So in our calculations, though, you want to take these coefficients and create them and put them into their new columns. Therefore, they are referenced for each of your samples that are unknowns in their quantities. Slope TC, slope TN. We're going to the coefficient in the linear model TC, subset 2. Coefficient, linear model TC. We're looking at the second one, 46.49. 46.49. That is our slope. Same thing with y-intercept. We're going to go to coefficient linear model TC under 1, which is the first listed one in our linear model. Intercept 55.1182, which is what we saw over there in the Excel sheet. We are still tracking the same information. Now we've just created 4 variables. They have not yet been added to our TCTN dataset. How do we add those in here and apply them to all of these rows so then we can calculate the amount of carbon in each of these samples? You have to create new columns by adding them in with the mutate function. You can combine them all very quickly and effectively with a pipe function. So we're saying here, in TCTN, we're going to mutate, and within it, we're going to make slope TC, which is up here. This is your new column name, equal this variable name. Slope Tn, new column name, equal slope Tn, variable name. Y-intercept Tc, y-intercept Tn, etc. So those are all of our column names. And what you can see in here now is you have slope Tc, slope Tn, y-intercept Tc, y-intercept Tn. Now this brings us to step 5. We implement the standard curve values for the slope equation to calculate the values of the samples that were run based on area counts. I'm speaking specific to my data. The fundamentals of this remain the same if you form any sort of linear regression and need to determine values based on that regression. We are doing simple quadratic formulas inside of R. So now we're going to calculate micrograms of carbon. We're going to create results in micrograms of carbon equals, and this is essentially solving for X in your slope equation, TC area minus y-intercept, TC over slope TC. Again, this is just following the quadratic formula. Nothing too difficult. You just need to understand that we're creating a new column that inputs the data following this equation. As you can see here, results in micrograms of carbon, results in micrograms of nitrogen. Now, we want to know a ratio. How many micrograms of carbon per milligram of sample, or nitrogen per milligram of sample? Add another column, and you do the new formula, micrograms of carbon over weight in milligrams. All this is simple math, simple algebra, put into R in a streamlined function. Stick around, hold on a second. Why is this math? Your workflow. If you see here, all of this can be applied to the same style of data over and over again. If you create hundreds and hundreds of points of data that need to undergo the same equations, this can be really effective for you. You're able to input the sheet. All you have to do is change the input line, run the calculation as such, creates all these extra formulas, it gives you your results in order, and then the only other option you need to do is create the new file to export it. Now, that is quite a simple function. So instead of clacking away on your keyboard to input all of your data, the R or in Excel, and then do functions within Excel, you can put a little effort into R, streamline your processing, and spit out your data and save yourself a lot of time down the road. So we've exported this, and as you can see here, we have all of the data that was just in R reflected here in Excel. So if you have people that you need to deliver the data to, here it is. You can send it off. It's comprehensive. Now, one last update that I have for you is as such. I have created a code blog with code seen in my prior videos. So if you like this video and want to have this code outlined in my blog, which will be linked in the description, please leave a like on this video. I hope you find this helpful and do understand that this isn't a one-to-one with your data, but it is a strong framework to streamline your data processing through R to save yourself a lot of time if you continually create the same style of data on a day-to-day basis. Right? Hopefully that's helpful.